All right, another logistic growth example. This model models the probability and percentage that that the number of people in a room, based on the number of people in a room, sorry, no two people share a birthday. So we want to know how many people must be in the room before the probability falls below 10%. It's much lower than the number of days in the year. It's very interesting the way that these probabilities work. So 10% is what we're going to put in here for our probability. And we're going to solve for, in this case, n, number of people. Again, our first step is going to be to get rid of the denominator. So we're going to multiply both sides by this thing that is monstrous to write. And the thing that I think one of the things that you have to tackle with these problems is just precision. Making sure that you get all of the right digits. Because if you leave out a 0 somewhere, it changes your problem drastically, and it can definitely make it so that you won't get the right answer. And it's not because your steps were wrong; it's because you dropped a decimal. All right, so 10 times this monster that used to be our denominator. And I'm double checking as I go. I'm kind of writing a little bit slower to make sure I get all of the digits that I need. 13.3198. Cool. I'm going to subtract, or I'm going to divide first. Divide by 10. Then I'm going to subtract over that 1. When I divide 113.3198 by 10, I just have that decimal moved. So I'm just going to move that decimal one place. The next thing I'm going to do is subtract 1. This time I don't have any fractions to deal with, so that's kind of nice. So I end up with 10.33198 here. Again, I'm going to let my calculator round. I'm going to try to do as little rounding as possible. The next thing I need to do, again, we want our e term by itself. We're solving for this guy first so that we can bring that the exponent down. So I'm going to divide by 0.115. And dividing by a decimal like that, that's less than 1, is going to make our number bigger. So when I do that division, I end up with 89.8433. And now I can take the ln of both sides. Now that I have my e term all by itself, I'm going to take the ln of both sides so I can pull down my exponent. Is 1. I'm going to divide by this 0.0912. And we end up with, when we do ln of 89.8433, and then divide that whole thing by 0.0912, we end up with 49.32 people. So about 49. Great.